These videos have been produced on-site in a large fabrication facility, and we ask your understanding for the environmental background noise. The Copper Development Association is pleased to present a series of video presentations covering the welding of copper-nickel alloy. This video is the fourth in a series designed to provide welders with the principles of joining 90-10 and 70-30 engineering grades of copper-nickel. To recap, in our first video, we covered preparation for welding. Maintain a high level of cleanliness and avoid contamination, which can cause weld cracking. Preheat and post-weld heat treatments are unnecessary. Here we consider shielded metal arc welding.
In this segment, we'll be demonstrating the shielded metal arc welding process, also known as manual metal arc welding. The process is one of the oldest used in welding, even today. It uses covered electrodes. It's especially used in situations such as field welding, where shielding gas might be blown away. It is an all-position process and produces very good welds. The plates that we're welding today have been prepared with a 35-degree bevel angle. Again, these angles are typically larger than you would use for carbon steel or stainless steels. This is due to the lower fluidity and the more sluggish puddle behavior of the copper-nickel welds. We'll be using 1/8 inch diameter copper-nickel welding electrodes. As with all the processes, the welding electrodes used have a composition of 70% copper, 30% nickel. These are used on both 70-30 copper-nickel alloy as well as 90-10 copper-nickel alloy that we're welding today. Often the first thing a welder will notice is that this copper-nickel weld metal does not flow as readily as ordinary steel or stainless steel. It is more viscous or sluggish, and it may be frustrating at first. Remember not to increase current, because the too high a current often leads to more problems and weld defects. Correct response is to stay within the recommended range. For this 1/8 electrode, it's 70 to 120 amperes. We're welding today at 100 amperes. You must accept this lower fluidity as a characteristic of copper-nickel welding, no matter what process is used. Notice again, with starting the next increment of weld to burn into the stop crater of the prior increment. Also make sure we keep a short arc length. Short arc length will avoid porosity and other defects, because a long arc will allow oxygen, nitrogen from the air to get in the molten weld metal and cause porosity. Again, the starting and stopping technique is the same as used with low hydrogen electrodes, where we go back into the start and we go back into the crater to be sure to fill the crater. As we're welding, we want to be sure that we weave the minimum amount necessary to get good fusion to the joint sidewalls. In no case should the weave be more than 3 times the diameter of the electrode.
After the weld is made, post-weld clean to a bright finish and visually inspect the weld to assure that it meets desired quality, the proper weld contour, and is free of defects such as cracks, undercut, and lack of fusion and penetration. Both the ID root weld, when accessible, and the weld face should be visually inspected. In addition to these video presentations, there is also free printed and downloadable literature covering all aspects of copper-nickel alloys, including fabrication, welding, and corrosion resistance.